Hello friends, my name is Rahul and welcome to my YouTube channel, Maths Made Simple. The idea here is for me to pick up a mathematical concept and make it easier for you to understand them. So if you like the contents that I'm going to cover today, please share and like this video, subscribe to the channel and post your comments as well. So without further ado, let's move on to the topic that we are going to cover today. Lines and angles, based on the contents covered in NCRT's Ganit Prakash for grade 6. Here you can see the list of elements that form the foundation of plane geometry. They include points, line segments, line, rays, and angles. So let's begin with points. Now, a point represents an exact location. It has no length, breadth, or height, and usually a single capital letter is used to represent a point. Here you can see the 3 points marked and denoted by X, Y, and Z. The next element is a line segment. Now, a line segment is a shortest route between 2 points, including them, and it has a finite length. The line segment from X to Y in this picture here is highlighted in orange and denoted by XY bar or YX bar. X and Y mark the endpoints of the line segment XY bar. Now the third element that we are going to cover is a line. Now a line has infinite length, and in this particular picture you can see the line that passes through the points X and Y. And how to denote it? It can also be just denoted by a letter N. Now, a line segment has a finite length, but a line has infinite length. So that's the major difference between a line segment and a line. The fourth element that we would look at is a ray. Now, a ray starts or originates from one point and goes on forever in a particular direction. In the picture, you can see the ray originating at point X and passing through the point Y, and how to denote it. Now, please bear in mind that while denoting a ray, the starting point is always mentioned first. So in this case, when we denote this ray, X would always come first as this ray originates from point X. The fifth and the final element that we are going to cover is angle. Two rays that originate from the same point form an angle. The point of origination is called the vertex, and the two rays form the arms of the angle. Now, in this particular picture, we can see that the angle are formed by the arms AB and AC, and both of them originate from the point A, which becomes the vertex. So we can denote this angle as angle BAC or angle CAB. But please bear in mind that always while naming an angle, the vertex would come at the center. Let's look at comparing angles. Now, the measure of an angle is the amount of rotation between the two arms that originate from a common point, which is basically the vertex. Now, in this picture, angle BAC is greater than angle YXZ. This becomes even clearer when you place one angle over the other, that is, via superimposition. However, in this particular picture, it's very evident that one angle is, far greater than the other. Now, what if the difference is a little more subtle and can't be identified just by looking at them? That is where measuring an angle comes into play. Now, for measuring angles, a circle is divided into 360 equal parts or units, and each of those units represent 1 degree. A protractor is used to accurately measure or draw angles. A protractor is a semicircular geometric tool which is divided into 180 equal parts, each of which measure 1 degree. Now, in the subsequent slide, we would see how to accurately measure angles using a protractor. Let's see here as to how we can measure an angle by using a protractor. Now, place the center point of the protractor over the angle's vertex. Adjust the protractor so that one arm of the angle is along the baseline of the protractor, which points to 0. While doing so, please ensure that the center point of the protractor remains at the vertex. Now, the question that may come is that a protractor has two markings, one on the inside and one on the outside, right? So, the question that would come here is which scale do I use? So, make sure that when you align your protractor, you need to use the scale wherein the 0 aligns with one of the arms of the angle. So in this case, while measuring angle BAC, we need to use the inner scale that starts from 0. And while measuring angle DAB, we need to use the outer scale that starts from 0. So once we have placed the protractor, what we need to do is we need to just read the measure of the angle where the other arm crosses the scale. So for example, while measuring angle BAC, we kept the protractor so that the center of the protractor aligned with the vertex A and the inner 0 degree was in line with ray AC. And here we can see that ray AB crosses the 40-degree line, which means angle BAC is equal to 40 degrees. Now, similarly, measuring angle DAB, right? Angle DAB is equal to 140 degrees. Now take a look at this picture. How do we figure out angle DAB? Now there are two ways that this could be done. We measure angle DAC and then we measure angle BAC and then find out the difference between the two, which is nothing but angle DAB. So angle DAC here is 55 degrees and angle BAC is 40 degrees, which means angle DAB is nothing but 55 minus 40, that gives you 15 degrees. Another way to determine angle DAB is to simply measure it by using a protractor. Now, in the previous slides, we have already seen as to how to measure an angle by using a protractor. So all you need to do is to align the protractor in such a way that the center of the protractor coincides with the vertex A and the arm AB of angle DAB is along the baseline of the protractor, which points to 0. So we would be using the inner scale here, and what we need to do is simply measure the angle where the arm AD crosses the scale, and that is 15 degrees. So angle DAB is equal to 15 degrees. Now that we know what an angle is and how to measure an angle, let's take a look at the type of angles. So there are basically six type of angles. The first one is an acute angle, wherein the measure of the angle is greater than 0 degrees, but less than 90 degrees. Then we have a right angle. A right angle is exactly measured at 90 degrees. After that, we have an obtuse angle, the measure of which is greater than 90 degrees, but less than 180 degrees. Then we have a straight angle, which is exactly at 180 degrees. Post that, we have a reflex angle that's greater than 180 degrees, but less than 360 degrees. And last but not the least, we have a complete angle, which is exactly 360 degrees. This is actually one full rotation. Let's now get into a rather interesting topic of clock and angles. We have already studied that when an angle makes a complete rotation, it completes 360 degrees. Now we know that the minute hand of the clock completes one full rotation in 60 minutes. Or in other words, the minute hand of the clock makes 360 degrees in 60 minutes. So how many degrees has it moved in 1 minute? It would be 360 divided by 60, which is nothing but 6 degrees. So the minute hand has moved 6 degrees in 1 minute. On the other hand, the hour hand completes one full rotation in 12 hours. Now, if we convert that to minutes, it would be 12 into 60 or 720 minutes. In other words, the hour hand makes one full rotation or it completes 360 degrees in 720 minutes. So in 1 minute, it would have moved 360 divided by 720, which is nothing but zero point 0.5 degrees. So the hour hand moves zero point 0.5 degrees in 1 minute. Now let's try to calculate the angle formed between the hour hand and the minute hand at any given point in time. And while doing this, we need to consider that when the needle is at 12 o'clock position, we will consider that to be 0 degrees. So then how do we calculate the angle formed between the hour hand and the minute hand? It's fairly simple. What we need to calculate first is the rotation that the minute hand has made from the 12 o'clock position, or the angle that the minute hand has formed from the 12 o'clock position, and then also calculate the angle that the hour hand has formed with respect to the 12 o'clock position, and then subtract them. So at 3 o'clock, the angle of the minute hand from the 12 o'clock position is 0. The angle of the hour hand from the 12 o'clock position is 90 degrees. Now, how did we arrive at that? Now, we know that the hour hand moves at the rate of zero point 0.5 degrees per minute. At 3 o'clock, the hour hand has moved for 3 hours or 180 minutes. So, its position from the 12 o'clock position is zero point 0.5 into 180, which is 90 degrees. Now the angle between the hour and the minute hand is the absolute difference between the angles of the hour and the minute hands from the 12 o'clock position. Now we have already determined that the angle formed by the hour hand with respect to the 12 o'clock position is 90 degrees, and the angle formed by the minute hand with respect to the 12 o'clock position is 0 degrees. So the angle between the hour and the minute hand here would be 90 minus 0, which is nothing but 90 degrees. Let's look at a more interesting example here and try to figure out the angle formed between the hour and the minute hand at 2 minutes past 3. Now at 2 past 3, the angle of the minute hand from the 12 o'clock position is 12 degrees. How did we arrive at that? We've already studied that the minute hand moves at the rate of 6 degrees per minute. So at 3:02, it has moved for 2 minutes. So its angle from the 12 o'clock position is nothing but 2 into 6, which is 12 degrees. Now at the same time, the hour hand has moved for 3 hours and 2 minutes. Or if we convert it into minutes, it would amount to 182 minutes. So the angle of the hour hand from the 12 o'clock position would be 91 degrees. And how did we arrive at that? Now we know that the hour hand moves at the rate of 0.5 degrees per minute. And we also know that at 2 past 3, the hour hand has moved for 182 minutes. So what do? We multiply 182 into zero point 0.5 and we get 91 degrees. And like the previous example, in order to figure out the angle formed between the hour and the minute hand, we would subtract their positions, or we would subtract the angles that the hour hand and the minute hand have made with respect to the 12 o'clock position. So in case of the hour hand, it's 91 degrees, and in case of the minute hand, it's 12 degrees. So the angle between the hour and the minute hand is nothing but 91 minus 12, 79 degrees in this particular case. The next concept that we would go through is angle bisection. Let's do it with the help of an example. Now in this particular figure, let's assume that angle BAC or angle CAB is equal to 60 degrees. Now ray AD is said to bisect this angle BAC if it divides it into two equal halves such that angle CAD is equal to angle DAB. And in this case, both CAD and DAB would be equal to 30 degrees. And the ray AD would be called the angle bisector of angle BAC. Let's now move to the final concept that we are going to cover in this video, which is drawing angles using a protractor. Now, I'll take you through a step-by-step guide as to how an angle can be drawn. Use a ruler to draw a straight ray and name it. In our example, we will name it as AB. Now this ray will form the first side of the angle. Now make sure that you place the midpoint mark of the protractor at the starting point of the ray, which would actually be nothing but the vertex. Ensure that the 0 degree line on the protractor lies exactly along the straight line that you have drawn in step 1. You will see two sets of numbers on your protractor, the inner and the outer scales. As explained earlier, choose the scale that starts with 0 in the direction your ray is pointing. Once you have the protractor aligned correctly, count from the 0 degree mark to the desired angle measurement and make a small dot on the paper at that point. Now, for the sake of this example, let's assume we want to draw an angle of 40 degrees. So what we are going to do is look at the scale from 0 to 40. And then at the 40 degree mark, we are going to just make a dot on the paper. Now remove the protractor and use a ruler to draw a ray from the vertex that passes through the point we just marked on the piece of paper. Now we can label it as AC. Now this is the second ray of the angle. So now we can finally label the angle with its degree measurement, which is angle BAC is equal to 40 degrees in this particular example. Finally, let's quickly summarize all the topics that we covered in this video. We went through the basic building blocks or the foundations of plane geometry. We saw what a point is, we saw what ray, line, and line segments are, and we also covered angles. While covering angles, we saw different ways of comparing and measuring angles. We saw the different types of angles. We saw the relationship of clock and angles. We went through the concept of angle bisection. And finally, we understood how to draw angles by using a protractor. I hope you found this video useful and thank you for watching this video. Have a nice day.